Junior Cert Exam 2016, Mathematics, Paper 1, Ordinary Level. This paper lasts 2 hours and there are 14 questions worth a total of 300 marks. Question 1, Part A. Write down the biggest possible 6-digit number. Write down the smallest possible 6-digit number that does not start with 0. Well, the biggest possible 6-digit number is going to be 999,999. What we do is we choose the biggest digit that is possible, which is 9, and we just write it 6 times. The smallest 6-digit number that does not start with 0. Well, the smallest 6-digit number, if we were not restricted by saying we can't start with 0, would just be 0000000. But since we are restricted with the very first digit that we can use, we choose the next smallest digit, which is going to be 1, and that becomes our first number, and all the rest are going to be 0. So this is 100,000, and this is the smallest possible 6-digit number that does not start with 0. Part B. Write in the missing number in each of the following sequences. Our first sequence is 3, 5, 7, and 9. We notice that there's a common difference of 2. We're going up by 2 each time. So we just have to add on another 2 to 9 to get us 11. So 11 is the next term in this sequence. In our next sequence we have 1, 4, 9, 16. And we notice that the difference is 3, 5, and 7. So the next difference is going to have to be 9, which means we have to add on 9 to the 16. And 16 plus 9 is 25, so 25 is the next term in our sequence. Or you might have noticed that these are the square numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so 5 squared would be 25. So the next term in that sequence would be 36, because 6 squared is 36, and then 49 because 7 squared is 49, and so on. Then we have 2, 4, 8, and 16. And we notice that what is happening is we're multiplying each term by 2 each time. So 2 multiplied by 2 is 4, 4 multiplied by 2 is 8, 8 multiplied by 2 is 16. So 16 multiplied by 2 will be 32. And then we have 10, 13, 16, and 19. And we notice that we're going up by 3 each time. So we have to go back by 3 and say 10 take away 3, and that's going to leave us with 7. Question 2. Dee, Moira, Ray, Evan and Fiona all use Snapchat. Dee, Moira, Ray use Twitter. Zach doesn't use Snapchat or Twitter. Use this information to complete the Venn diagram below, where U is the universal set. So the set on the left represents Snapchat, the set on the right represents Twitter, and D is already given to us in the intersection. Then we want to list the elements of each of the following sets, where S dash is the complement of the set S. Then we want to get S intersection T and S complement. So what we want to do first of all is see which elements are common to both. So I've highlighted in yellow the 3 elements, the 3 people that are common to both. So Dee, Moira and Ray are going to go into the intersection because they each use both Snapchat and Twitter. Then I'm going to see what's left over in set S, which is the Snapchat set. So I've got Evan and Fiona. So they're just going to go in this section here because they use Snapchat, but they do not use Twitter. Then I'm going to do the same, and I'm going to have a look and see who's left over in the Twitter set. And there's actually nobody else left over, so we're not going to have anything in here at all. Because each of these people use Twitter, but they also use Snapchat, which is why they're in the center. They're in the intersection. And then we have Zach, and he doesn't use either of them. So he just goes in the space inside the rectangle, which represents the universal set. It doesn't matter whereabouts he is. Make sure that each of your elements have a dot beside them. So Then we're going to have a look and see what's going to go in this box here. So this represents S intersection T. So intersection is what's in the middle. So it's going to be D, Moira and Ray. And then S complement is basically everything without S. And since this is set S here, if we are not to include anyone in this set and only include anyone that's outside this set, we're only left with Zach. However, if there had been someone in here, we could have included them as well. Part C. Put a tick in the correct box in each row of the table to show whether the statement is true or false. So we have to use our Venn diagram that we just completed, and we need to see if these statements are true or false, and we put a tick inside these boxes. So the first statement is the cardinal number of S, so that means the number of elements in S is 3. So let's have a look at S. This is set S, and we can see we've got 1, 2, 3, 4, 5 elements in set S, so that is false. Our next statement says D is an element of T. So is D inside of set T? So this is set T, and we can see that yes, D is inside set T, so D is an element of set T, so that's true. The next statement says that S union T is equal to T union S. So S union T basically means all the elements in S and all the elements in T put together. So Evan, Fiona, Dee, Moira and Ray. And then T union S means the exact same thing. All the elements in T and all the elements in S put together. So yes, that is true. They are equal. Then T subset S. This means T is a subset of S. So let's have a look at set T. And in set T we have D, Moira and Ray. And then we have a look at set S. This is set S. We have Evan, Fiona, Dee, Moira and Ray. And yes, it is clear to see that Dee, Moira and Ray are a subset of set S. So they're in T, they're in set T, but they are also in set S. And there is nothing else in this space here, so it is true. Okay, and then we have S dash T, so this means like S without T. So if we were to include S and not include T, would we be left with the null set or an empty set? And that is false. So just to summarize, this symbol here means the cardinal number, which means the number of elements in a set. This symbol here means is an element of. If we had this symbol with a dash going through it, it would mean is not an element of. This symbol here means union, so every element in set U and in set T. This symbol here means subset, and this symbol here means the null set or the empty set. But these symbols are all given to you in the formula tables. Question 3. The graph of the function y equals h of x is shown on the coordinate grid below. So this is the coordinate grid, the xy axis, and this is the function y equals h of x. The graph is made up of two line segments. So here's the first line segment, and here's the second line segment. Use the graph to answer the following questions. Find the value of h of 4, and what number must this symbol represent if h of that symbol is equal to 12? Okay, so when they say use your graph, you literally have to draw on your graph, and they want to see that drawn in. So we're trying to find the value of h of 4. Now if you notice up here in the question, they said y equals h of x. So beside the h we had a set of brackets and we had an x inside it. So down here we have a h and a set of brackets and a 4 inside it. So what we're going to do is go to the x-axis and we're going to go to 4. So this is our x-axis. This is always the horizontal line going across. So we go to 4 and we're going to draw a line up until we touch our graph using a ruler, and then we're going to draw a line across to get to the y-axis. So h of 4, because in our equation we were given y equals h of x, and now we've swapped the x for 4 in our question, so we go to the x-axis and we go to 4, we draw a line up until we touch the graph, a line across until we touch our y-axis, and we end up at 3. So h of 4 is equal to 3. If, for example, we were asked to find h of 5, we would go to 5 on the x-axis, draw a line up, and draw a line across until we got to our y-axis. So h of 5 would have been 3.5 or 3.5. If we were asked to find h of 8, we'd go to 8 on the x-axis, draw a line up and a line across, and we'd end up at 5. So h of 8 would be equal to 5, and so on. Now part 2 says, what number must smiley face represent if h of smiley face is equal to 1? Now it can be a smiley face or it can be any symbol, it can be a letter, they just have a smiley face in this example. But if we have a look back at our equation that we were given, y equals h of x, and we now have h of smiley face is equal to 1, well, we can just say y is equal to 1. So this is the same thing as saying y is equal to 1. H of x is equal to 1 or y is equal to 1. So what we're going to do is go to 1 on the y-axis. So this is our y-axis here, it's our vertical axis. So we're going to go to 1 and we're going to draw a line across until we touch our graph and a line down and we get to 2. So the answer is going to be 2. So when h of smiley face is equal to 1, we go to 1 on the y-axis, we draw a line across and a line down until we get to 2. So 2 is our answer. If it said, for example, h of smiley face is equal to 4, we go to 4 on the y-axis, draw a line across and a line down, and we'd get to 6. So h of smiley face equal to 4, the smiley face would represent 6. So it's just the opposite of what we did a minute ago. Okay, part B says use the graph above to fill in the 2 missing values in the arrow diagram below, which shows the value of h of x for the given values of x. So these are our values of x, and these are our values of h of x, or values of y. H of x and y mean the same thing. So we're trying to fill in these missing boxes, but we have to use the graph. Okay, so if I just start having a look at my values of x, so the first value of x I have is 0, and this is telling me that if I'm at 0 on my x-axis, I'm going to be at minus 1 on my y-axis, because h of x is equal to y, or y is equal to h of x, means the same thing. So let's check, is that right? If I start at 0 on my x-axis, do I end up at minus 1? So this is 0 on my x-axis, and yes, when I touch my graph, I end up at minus 1, so that's correct. This statement is correct. Now it's saying if I start off at 5 on my x-axis, do I end up at 3.5 on my y-axis? So I'm going to go across my x-axis to 5, I'm going to draw a line up and a line across, and yes, I would get to about 3.5. So then I'm going to have to do the same thing, so I'm going to go to 6 on my x-axis, which I've circled in red, I'm going to draw a line up, touch my graph, draw a line across, and I get to 4, so I'm going to put 4 in that box there. And then in the next part, I am missing a box in my x value section, but I have a 5 for my y value. So I'm going to go to my y-axis, I'm going to go to 5, and I'm going to work backwards to try and figure out what this number is. So I go to 5 on my y-axis, I draw a line across until I touch the graph, I draw a line down, and I get to 8. So 8 goes in that box there.